relatively easy to learn. A number of people use calculator programming as kind of a gateway to get younger children or even early high school students into the idea of computer programming and or writing codes or scripts of any kind, similar to what is done often with Microsoft Excel and writing formulas and code inside spreadsheets and things like that. It's just a way to get kids a taste of what computer programming is like and what you can get a machine to do by using correct commands. So this is going to be the first of a 4-part series on programming the Casio graphing calculators. We're going to be using different calculators for each of these sessions. This session, as you can see on my screen here, is going to use the Casio FX9750G2. This is the most basic of Casio's graphing calculator line. This calculator is available for around $50, so it's a very affordable kind of entry-level graphing calculator, but one that can accomplish anything that you need done in the high school curriculum. And one of the reasons we're using different calculators for each of these sessions is because whether you look at this particular unit or you look at one of the other Casio high school graphers, you will see all of the same keys on the keypad in the same places. The keypad might be a different color. What those keys do as far as functionality is going to be basically the same, and the only difference is that you may see maybe on the screen and some of the options that are available on screen. So no matter which Casio grapher you pick up, you're going to see a main menu, and if you do not see a main menu, you can always get to that main menu by pressing the menu key here. And on that main menu, either on the initial screen or maybe you'll need to scroll down on another unit to see it, but one of the icons that you will see on any of those graphers is the programming icon, which on this calculator is down in the lower left-hand corner here. And you can see that in that icon is the number 9. So that indicates to us that we can simply press the number 9 and visit that icon and enter the programming mode. We could also have gotten there by looking at the main menu and using our arrow keypad to go down to highlight the programming icon and press the blue execute key in the lower right-hand corner. One of the things you're going to notice during this webinar is that I have the recording option turned on in the calculator emulator software here. So you should be able to follow through, rewind, fast forward if you're watching this webinar not live later, and you should be able to look through and see the different keystrokes that I've been using. So when we first hop into programming here, here's our program list. You can see we don't have any programs in it. There are no pre-stored programs loaded on the Casio calculators when you purchase them. This is entirely a user-based programming area, so if you haven't created a program, you shouldn't be surprised to not find anything there. We're given a prompt here at the bottom of the screen that says New, and of course when we are actually looking at the calculator proper, this New word would be directly above the key F3 here. So this is what we call a soft menu, a menu controlled by the software, and anything you see at the bottom of the screen here as the menu option is controlled by these F1 through F6 keys. So we're going to press the F3 key to create a new program. I'll move the keypad back here for a moment. And we now have the option to input a program name. You can see a little flashing cursor with an A above it. That indicates that by default our cursor is in alpha lock. That means that any typing that I do needs to be some kind of words. In addition, you should know that the program name can only be 8 characters long. And so that means we can't use anything more than an 8-letter word, and there are certain special characters that we can use, and that's accessed by pressing F6 for the symbol area, but you only get a few choices. There are not a whole lot of special characters that are allowed in program names. For the purposes of tonight's program, I'm not going to use any special characters, so after looking at that menu, I'm going to press the exit key to get out of the symbol menu. And you notice that my cursor now has turned back to just a vertical flashing cursor. I'm no longer in alpha lock mode, and that was because I was accessing the symbol menu, and symbols are not considered alphabetic characters. So you may want to watch out for that. If sometimes it may be confusing that you go to the symbol menu and come back, and you can, if you start typing things, all of a sudden you have numbers instead of letters. If that happens to you, it's okay. Just press the delete key here, DEL. It works like backspace on your computer. And then to return to alpha lock to type in a program name that uses letters, just press the shift key in the upper left-hand corner here. See my cursor changes to an S to tell me that shift is active. And then the alpha key, because alpha lock is in gold here, which means it's the option accessed by pressing shift first. And now I can type alphabetic characters. For each of these programming webinars in this 4-part webinar series, we're going to be learning about a certain set of the Casio programming commands. And in order to do so, we're actually going to write a usable program that makes use of those particular commands. So tonight we're going to write a simple formula or a simple program that allows a user to type in the values of A, B, and C for a quadratic equation in standard form, and then performs the quadratic formula on those values. So we're going to title this program Quad Form to use all of our 8 characters. So you see I'm pressing various keys here, but the thing to pay attention to is these red letters that are on top of those keys. So I pressed 5 and 1 to get the Q and the U, and I'll continue with A, B, F, O, R, M. And when I'm satisfied with my program name, I'll press the blue execute key in the lower right-hand corner. Now we have a question from one of our participants tonight that
Can't hear you there, Mike.
is asking if there's anything in the keys so you can see the keystrokes stored in the keylogger area so you know exactly what I'm pressing. But for example, if I wanted to type a message here to you, I can begin typing using my keyboard, and it would do the same thing as if I had pressed the keys here. Does that answer the question that was asked? Looks like the hand has been lowered. So you can type on the keyboard. I'm not going to be doing a whole lot of that tonight because, again, I want you to be seeing the keys that I'm pressing if you are using a handheld unit. So we have a blank program with a title. And let's do a little bit of exploring of the menus that are at the bottom of the screen. Again, these are soft menus, and they will be using the F1 through F6 keys here. Anytime that you see a soft menu that has a white background, like this one that says top, and this BTM, which means bottom, and this one above F5 that has an uppercase A and a lowercase a, when you have a white background in a soft menu, that means that pressing that key is instantly going to do something. So, for example, F1 and F2 are going to be very useful as our program gets longer because it's going to allow us to quickly move to the top or bottom of our program. Right now, pressing those keys doesn't really seem to do anything because I'm at the top and bottom of my program right now. I don't have any lines of code written. But if I press one of the other keys where beneath a menu item that has a black background, that indicates that I'm going to open another submenu. So for instance, if I press F3 to find out what this SRC thing is, it brings up another menu or prompt here where it's allowing me to search for text in my program. So say for instance I had 150 lines of calculator program code written here, and I knew that somewhere I had included a particular command. Let's say I had included a label command that we'll learn about later. If I wanted to go and search for the text for that label command, I could type in LBL for label just by using those same alpha keys that we did before. Shift alpha lock, and I could type in L. And now I'm going to press F5 to change to lowercase letters. You can see my prompt changes to lowercase here. I can type in LBL, and it would search for this command called label. And it says it's not found, of course, because I don't have any text printed. So I just press the exit key to get out of that search. But the main thing I want you to understand is when you see a black background, that's going to bring up a new menu of some kind. If I press F6 for characters, F6 brings up a whole lot of various characters that can be used to display in your program. Lots of mathematical things, lots of symbols, different arrows, and different kinds of quotes. You have characters from different international alphabets. You have Greek characters and other diacritical marks. And then you have much, much smaller upper and lowercase letters. So lots of different choices for characters that are stored there. We're going to start very simple with our quadratic formula program. And in order to write this program, we need people to give us some inputs. We need people to tell us what their quadratic equation looks like. What are the values of A, B, and C? So we're using this program because we're focusing tonight on inputs and outputs. How can we write a program that gets the user to type in information into our program, and then how can we display the outputs of that program in a way that's easy for the user to see and understand? So let's first find out where all of these programming commands are. These menus down at the bottom of the screen are mainly for changing what kinds of things you type and for navigation throughout your program. The main programming commands are actually sitting here. In gold it says PRGM above the variables key. And since it's in gold, we will access it by pressing Shift first and then variables. And now you see I get a whole new menu at the bottom of my screen. I also have a right-facing arrow above the F6 key, and that indicates that there's another page of choices. If I press F6, you can see even more programming menu choices there. Pressing F6 again shows that there's yet one more menu, and pressing it a third time returns us to the original screen. So let's talk about inputs. Suppose we want our users to input the value of the variable A. We're going to use this question mark. This question mark is an input prompt. So we're going to press F4, and that's going to create a question mark for us. And that is a command that will also create a question mark for the user. What we now need to do, the proper syntax for this command, is to take whatever the user inputs, which is represented by this question mark, and store it into the value of a variable. So since the first thing we would like the users to type in is the value of A, we're going to have our question mark here, and then we're going to type the storage arrow, the right-facing arrow. It's on the right side of the keypad here. And then we'll press the red alpha key. and the key directly beneath it has a letter A. I didn't need to place my keyboard in alpha lock because I only had one letter to type. So if I only have a single letter to type at a time, I can just press the red alpha key, and that makes the next character I type be one of these red letters. So we have question mark being stored into the variable A, and we'll now press the execute key to mark that line of code as complete. So when we see this is a little carriage return character here, and this means the end of the programming line. We now have a functioning program. It only does one thing. It currently only gives a prompt and asks the user to type in a number, and then it stores it in the variable A. But any good programmer on any platform knows that it is good to do frequent testing of the program. So let's go see how this looks. We're going to press the exit key. That gets us out of the programming menu, and press the exit key again. And that brings us back to our program list, and now we have a program in our program list. Here's our program quad form, and this number 36 on the right-hand side indicates the number of bytes of data that this program is occupying in memory. So as we write more and more lines of code, you will see this number grow. If we would like to run this program, we can press the F1 key to execute the program, or we can simply press the execute key on our keypad. Let's run our program. Very boring. We get a question mark and nothing else. So think about a user who is running our program and has not been the one that's programmed it like we have. They have no idea that this has anything to do with the letter A. So we know that this is going to be stored in the letter A. We could type the number 5, for instance, and press execute. And the calculator confirms the number 5 and does nothing else for us because we're not asking that the calculator do anything else in our program other than store a value. If we now went to the main menu and up to the run matrix area of the calculator, which is where we run calculations, and type alpha A, we would get confirmation that yes, indeed, the number 5 was stored into the value of A. But that's a pretty boring program and difficult for a user who's never seen it before to understand. So let's press menu again and go back to our programming area. I'm just going to press the number 9 to hop there quickly. And now we want to go back into our program and do some more editing. So I'm going to press the F2 key for edit. And we're right back inside our program where we were typing before. We would like to provide the user with a prompt, some kind of text that tells them what we are asking them to do. Hopefully, when they see quad form, they may have the idea that this program has something to do with the quadratic formula, so we may not need to say a lot about that at the top of our program. If you'd like to add some text for that later, you can do so. But right now, we're just going to add some text in front of our prompt. So we would like to tell the user what they are entering. So let's press the Shift key and then alpha to place our calculator into alpha lock. And then I'm going to create a quote, which is down in the bottom center of the keypad. You can see the red quotation marks here. And notice that our cursor, just like a word processor, by default inserts text. So we don't need to worry about overwriting our question mark or our arrow or our A. They're just going to get moved over as we type. So we could say, for instance, enter, and then I'm going to create a space by pressing the decimal point key here. You see it says space above that. Enter the space value space, of, space, A. And then I'm going to type a closing quotation mark and leave the question mark after the question I'm asking, and the arrow and the A just as they appear here. So I'm going to press the down arrow to move to the next line. I don't need to put another carriage return in because there already was one at the end of my line. Even though this line wraps around from line to line, this is only one line of code. I'm limited by how wide my calculator screen is, but this carriage return is the only thing that tells me that my line of code is completed. So now I'm going to press exit. You notice my program has grown in size from 36 bytes to 60 because of the text I've entered. And let's run the program. Now it says enter the value of A, and I can type 5. And now I have a little better idea of what I'm being asked to enter. But notice that even when we enter text, we still have a question mark. And this isn't really a question. This is more of a command to the user. Enter the value of A should be followed by a colon or a period. So if we want to phrase it as a question, we can probably lose the words enter the and just say value of A question mark. So let's press exit, go back to our program list, and F2 for edit. And I'm just going to move over and place my cursor immediately before the V of value and press that gray delete key a number of times until I've removed the words enter the. Now I'll move on to the next line, and we'll continue from there. So we can now type in another couple of commands that ask for the values of B and C. So we're going to follow the same syntax here. Shift alpha to place the calculator in alpha lock, quotation marks, value, space, of, space, B, close quotes, and now I need to go and get that question mark command again. You cannot just go into the character area and find it any old question mark and place it. You must get the question mark from the program commands. I mean, a text question mark means something totally different to the calculator than a question mark that comes from the programming command. So remember the programming commands were PRGM here above the variables key. So we'll press the gold shift key and then variables to get into the programming area. And then here's our question mark. We'll press F4 to create the input question mark, and then the storage arrow, alpha B, and press execute. Any questions about what we've done so far?
There was one question about the layout of the program commands on the other calculators. I think you went through it real quick, but just to reaffirm, let people know, I think they're the same in all of them. Other than that, I think it was okay.
The programming commands here at the bottom of the screen are all the same on the other calculators as well. What you may find as you go up the line with some of the higher model graphing calculators in Casio's line is once you get to this third page here, you may see one or two additional menu options appear. There may be additional programming commands that are available on those calculators, but I want to stress that everything we are doing here tonight could be done on the 9750 calculator, the 9860 calculator, or the Prizm, and you can use exactly the same keystrokes that I've shown in the keylogger here to get to those. So this first page, second page, and the third page with the string commands are going to be the same on all of those units. You may see one or two additional menu options appear. And as we go through the series of webinars and we get to especially sessions 3 and 4, which are going to be done on the Prizm calculator, we'll actually talk about some of those more specific unit-based command menus.
Thank you. That takes care of it.
Okay. One little trick that I want to show you here. Let me quickly go into my keylogger, and I'm just going to clear this out for us so that we can start fresh. One trick I want to show you, since we're going to have 3 lines of code that are going to look very similar, the only difference is going to be the letters A, B, and C, is the ability to copy and paste on the calculator itself. So I'm going to press the up arrow so that I have my cursor on at the beginning of this value of B line. And then copy and paste on the calculator is done with clip and paste, these commands above the numbers 8 and 9. So if I'd like to copy this entire line of code so I don't have to retype everything, I can press Shift and the number 8, and then you see that I get a little copy icon at the beginning of this line. And I'm going to use my right arrow, and it's going to gradually highlight this line. I don't want to cut the line of code because I want this line to stay there, but I'd like to copy it so that I only have to change the letters B to C. So I will press the F1 key for copy here, and now simply down arrow to the next line and press Shift 9 to paste. Now this is a relatively short line of code, but you will find as you continue to write programs that you may have situations like this where the lines of code are much longer, or you have entire sections that you would like to copy. And this can be a really, really fast way to do that. So I'll now arrow to the right of that first letter B, press the delete key, and then alpha C, and do the same thing later in that line. Delete that B, and press alpha C. And now I have a program that prompts for the values of A, B, and C. So again, let's be good programmers, and let's exit back to our program list and test our program by pressing execute. Value of A, let's say it's 5. Value of B, let's say it's -2. And the value of C, let's say that it's 1. And notice the calculator just outputs the very last thing that we input because it doesn't have any instructions for us as to what to output from the program. We've successfully stored 5 into A, -2 into B, and 1 into C. And so this has now shown you how we can input numbers and prompt for input from our users. And now our next step is going to be to create an output. So let's press the exit key and F2 to edit our program. And let's go down to our 4th line and write a couple more lines of code. So if we have now the values of A, B, and C, we can now create a calculation that calculates the values of the quadratic formula for these values of A, B, and C. So if we were to just start typing what we know about the quadratic formula, okay, x equals,
Mike, check your microphone there. We're losing you.
I can do shift in the period. There are actually 2 values generated most of the time by the quadratic formula. Only when the discriminant is 0 are we going to get a single value. So we're going to need to create 2 different calculation lines in order to show those 2 different values. Maybe we can call them x and y for now. There's not really a nice way to call them x1 and x2. We have to use single alphabetic characters as variables. So we'll just start here and say x equals negative b plus, and then we'll create a radical by pressing shift and the x squared key. There's our square root. And we'll type parentheses alpha b squared minus 4 alpha a alpha c, close the parentheses. And now this all needs to be divided by 2a. So we need to do this carefully. We need to create another set of parentheses around this entire quantity. Oops. And then we need to go to the end of that set of parentheses and divide it by parentheses 2a. If we don't include those last set of parentheses here, it would just take this entire quantity, divide it by 2, and then multiply it by a, because the calculator will do what it's told and obey the order of operations moving from left to right. Press execute, and let's see what happens when we write that line of code. Press exit and execute to run the program. Value of A, 5. Value of B, -2. Value of C, 1. And we get an error. Non-real error. Hint, hint. This is not a real number. Press the exit key. Our cursor is showing us exactly where the error is occurring in the program. So if you encounter error messages, that's going to happen sometimes as you learn to program, whether for the first time or just in this calculator language, as you learn the proper syntax. But the cursor is showing you where the error occurs. And what do you know? It's right at the end of the discriminant. Well, let's think about the values we put in. B squared minus 4ac. B squared would be -2 squared, which is 4, minus 4 times a, which was 5, and c, which was 1. We're going to have 4 minus 20, and we're going to get a complex number as a solution. We get a negative discriminant, which means we have 2 non-real roots. And for the purposes of this program tonight, we're just going to concentrate on writing a program that finds real roots. You can certainly modify this program later and do a lot of nice things with it to have it tell you what kinds of roots are coming out, have it evaluate the discriminant first, and make some decisions based on that. But again, we're just going to write a simple program tonight to deal with inputs and outputs. So let's assume that that non-real error was our only problem. We'll press the exit key and execute the program again. And this time, let's mix around our values and make sure that we're going to get a positive discriminant. Let's have a value of A that's 1, a value of B that's 5, and a value of C that's 2, and see what happens. We get an output of 0. What is this output saying? Well, let's see if it actually stored the value of x correctly. We'll go back into our program and figure out what the value of x should have been. B was 5, so we would have -5 here, plus the square root of 25 minus 4 times a, which was 1, and c, which was 2. That's 8. We'd have the square root of 17. It certainly doesn't look like this is a value that's going to turn out to be 0. So let's go investigate. Press the menu key and number 1 for run matrix, where we perform our calculations. And let's just type an x, do alpha x. And it tells us the value of x is 0. Very strange, since our calculation didn't seem to attribute a value of 0 to x. Well, this was an intentional error on my part to show you why it's important to use proper syntax in these programs. When you type this line, x equals, which is very common programming speak. There are a lot of programming languages, especially on computers, and this will be important if you have students that have done any computer programming on their own before picking up a calculator. A lot of programming languages start out with defining a variable by simply saying the variable having an equal sign, and that attaches this value to this variable. This is not true on the calculator. The calculator is actually going to look at this statement and evaluate the statement to determine if it is true or false. So the way we've written this line right now, it's asking the calculator, is the value of x that you currently have stored equal to this calculation? Well, you just saw that the value of x in the calculator was 0, and we know that this expression on the right side is not going to turn out to be 0, so the calculator says that's false. And the way it tells us that it's false is by outputting a 0, which it did at the end of our program. If it were true, it would output a 1. So in order to actually store this value into x, we need to use the same arrows, the same storage arrows that we were using up here for A, B, and C. I can make that change with just a little bit of editing. Move to the right of the equal sign here, press delete twice to get rid of the x and the equals, and go all the way to the end of the line. Right after the last parenthesis, place a storage arrow, and then type alpha x. Exit, execute to run the program, and now let's try 1 and 5 and 2. Oh, there's a new value. The calculator is outputting for us the last value that it calculated. We have not told it to output this value, but it assumes that that's the value we want output because it's the last thing that was calculated. So we have one of our roots of our quadratic equation. Now we just need the other one. Let's exit, F2 for edit, and here's where we can use copy-paste to our advantage again. Shift-8 for clip. I'm just going to press the down arrow a couple of times, and it's going to select my entire line at a time. I'll press F1 for copy, go down to the next line, and press Shift-9 to paste. And if we know our quadratic formula well, we realize the only thing I need to change here is changing the plus in front of the radical to be a minus sign. And then I, of course, need to go to the end of my line and store this into a different variable. We don't want to store the first root into x and then overwrite it with the second root. So I'll press delete here and press alpha y. Should create a different root. We'll press exit and execute to run our program. A is 1, B is 5, and C is 2. And now we definitely get a different answer than we did last time. The problem is that we're not seeing both roots. And we would like to see both roots. So this is where we have to tell the calculator to output certain things. Otherwise, it's just going to spit out the last thing that was calculated in our program. So let's go back and edit our program again. And this time, move down to the bottom of the program, and we're going to learn about our output commands. So, shift variables to get back to our program commands. And now what we'll do is we'll force the calculator to show the value of x by pressing alpha x. And then this character that's just to the right of the question mark, which is a triangular shaped thing, I want you to think of this as an arrow pointing down and to the right. That's a character that has sometimes been used in computer programming for output. Send this out to the screen, the user. So we're going to press the F5 key to create that little character, and you notice it pops to the next line. That's a hint to us that we don't actually need a carriage return here at the end of this line. That output character is automatically at the end of the line. You cannot type anything else after this that makes sense in this programming line. This just says take X and output it, and now we'll type alpha Y and the F5 key and say take Y and output it. And let's see how that looks from the user's perspective. Exit a couple of times, and then execute to run the program. Value of A, 1. Value of B, 5. Value of C, 2. And now it shows us the value of X, and this DISP simply means that our display is paused so that we can see this value, maybe write it down if we're doing a problem that involves these values of A, B, and C. And if we press the execute key, it will move on to displaying the next value. And so now we can very easily see both of those values, one right after the other. There are both of our roots. We can jot them down. We can round them if necessary. And pressing the execute key one more time, it will display the last value again, because that's the last value calculated, but we don't really care that it's displaying it twice. Again, there are lots of things we can do to clean up this program so that it won't display these two values twice. We could go back in and have it not display Y, for instance. That's a quick cleanup. Let's go do that. Exit F2, scroll down to the bottom of the program, and let's just go and delete our Y line here and have only an X line. And if we execute the program, A is 1, B is 5, C is 2, there's X, and now it displays X twice. Why? Because it's displaying the last thing that we asked it to do. So you can see that it's the calculator's last output once we exit out of the program is going to be to display the last thing that was printed, the last thing that was calculated. So we do, after all, need to have a Y line there. We'll type Y and go into our programming commands and get that output character. But one of the things that we can do now to force the program to end is to tell the calculator that the program has ended. Don't just leave it hanging. And we do that by going to the next page of commands. And here you can see some of our additional menus here. We have F1 is the ability to clear the screen. You may want to use that at the beginning of your program. F2 has some display options that we'll use later. Just walking you through a couple of these menus. F3 has relation symbols that you may need to use. F4 is input-output, and we'll be using some of those in our webinar next week. But the command that we want is actually back on our first screen, where you have the ability to jump. You have the ability to take control of the program, and that's where the magic command is that we want. We want our program to stop. So, from your first programming screen, we got a hand raised asking, where was that in the menus you flew through? I'm sorry about that little adventure through menu land. But let's press the Shift key and variables to get to the menu, the programming menu commands. And CTL is control of your program. If you press F2 for control and then press F4 for stop, that's going to tell your program to stop running. Let's press exit a couple of times and execute our program one last time. Value of A is 1. Value of B is 2, or it's 5, excuse me, and value of C is 2. There's our display of X. There's our display of Y. And even with a stop command, we still are going to get that last value of y. So we have a little hanging annoyance at the end of our program that I will teach you how to resolve in our next week's session when we will learn to output things as lists. Until that time, you have a program now that calculates any two real roots. I'd urge you to play around with it. These are not meant to be comprehensive, totally complete, totally edited and bug-fixed programs. They're just meant to give you an introduction to certain types of commands. So realize that you now know how to get the calculator to input values and how to get it to output values, a couple of basic commands. Play around with this program. Try to modify it and suit your own needs. Try to make some edits to the program that personalize it and make it yours and make things appear the way that you'd like them to. And please feel free to bring questions to next week's webinar, which will be held on Wednesday, January 30th at 6 p.m. Central. And in that program, we're going to begin working on loops, programming loops, and we're going to write a program that will determine whether or not a number is prime. And I would certainly welcome at that time any questions that you might have about the program that we use this week, whether you've been watching this live or whether you've watched the recorded version of this webinar after the fact. That's available on CasioEducation.com. Or any programming questions that you come upon. Please feel free to submit those ahead of time or during the webinar next week or in the weeks to come. So thank you for joining us tonight. I hope you enjoyed writing your first Casio program, if it was your first, and that you'll be able to use some of the commands we learned tonight to write your own programs and experiment with your students.
Thank you, Mike, and thank you for having the keystrokes on the side. I got a couple of comments on how that was very helpful and very nice to catch on and watch what's going on. And like Mike said, next webinar will be next week, same time, same place. Mike will be continuing his series, his 4-part series on programming. So thanks again, Mike. Thanks, everybody, for joining us. All the questions have been answered. All right, take care.